CLO2.1, draw and interpret scatterplots to determine the nature of relationships between variables. Okay, to start off, in this course, in the previous learning outcome in LO1, we only dealt with one variable at a time. We talked about asking survey questions that had one question, like, what is your favorite color? Or how old are you? Or what is your GPA? But in LO2, we're going to do questions and deal with issues involving two variables. So similar to what we did in LO1, but now we're going to ask two survey questions or collect two pieces of data. And the idea is we're going to try to see if, when we collect information about two pieces of data, if there is a relationship, if we can see a pattern. So for example, we might ask a bunch of children, how old are you? And then measure how tall they are and see if there is a relationship. Or we might measure the speed limits on certain highways and the number of accidents on those highways and see if there is a relationship. And when we collect our data, we put them in two categories. The first category of data we collect, we call X. And then the next category of data we collect, we call Y. Now, it turns out that it does matter which data you label as X and which data you label as Y. The X is what we call the independent variable, and that's the variable that you want to think of it as it comes first. It's the one that if you're a scientist doing an experiment, it's the one you have control over, that you can change. And usually the second variable, called the dependent variable, is the one that gets affected. Okay, so for my previous example on my previous slide, when I said age of a child and height of a child, the independent variable, the one that comes first, is the age. We can just find children of different ages. That's what the scientists would do if they were trying to collect data. And that, we presume, would have an effect on the height of the child, which you measure. Often the dependent variable is something that you measure, that you see the result after you manipulate the input or the X variable. My other example from the previous slide was speed limit as compared to traffic accidents. So again, the speed limit is something you can set. It's something that we can collect our data from different highways with different speed limits and then measure and see how does that affect the number of car accidents. So that would be the independent variable. Okay, so we'll do a few examples on the next slide where we're having to choose which variable should be independent and which should be dependent. So let's look at this next slide. A scientist is doing an experiment and they want to see how vitamins extend a person's life. So the thing that the scientist changes, the thing that the scientist has control over, is usually called the X, or the independent variable. And in this case, it's the vitamins. How many vitamins, what quantity, how often a person takes these vitamins. And then the dependent variable, the effect, would be the Y variable, and that would be the person's life expectancy, how long that person is going to live as a result of those different amounts of vitamins. Let's look at one more. So we have another one, a scientist. He wants to do an experiment to test how the different driving speeds will affect the braking distances. Okay, so how long it takes for a car to brake if they're going different speeds. So again, the thing that the scientist has control over is called the independent variable. The scientist can control the different speeds of the car and then measure how long it takes under each circumstance for the car to come to a stop, braking distances. Okay, so those are examples where you have to decide using your logic what comes first, what is, we could say, the cause. That's the independent variable. and what comes second, the thing that you measure, gets affected by the x, the dependent variable. So the independent variable is x, that's the cause or the thing that comes first, and the dependent variable is the y, that's the thing that you measure that gets affected. Now, once you collect your data, a very popular way to display the data is using a scatter plot. So remember, we've got two sets of data we will have collected. We've got an x and a y, an independent and a dependent, and we will visually represent them in what's called a scatter plot. So you always put the independent variable on the x-axis and the dependent variable on the y-axis. Let's look at this first example, the amount of time spent studying and the final grade in a course. So I think your study time is the independent variable. That will have an effect on your final grade of the course. And use your logic. I predict that the more you study, the better your grade. So if we were going to take people and their low study time would probably be a low grade, high study time hopefully would be a high grade, and you might get different results with different people like this. This is what we call a scatter plot. And these dots, each dot represents one person, and one person would share with the interviewer how much did they study and what were their grades, and we would map it as a dot on the graph. Okay, when the dots are going up and they look like a straight line, this is what we call a positive relationship. It's where the dots look like they're making a straight line going up. It doesn't have to be perfect, but just the pattern fits that line pretty well. Let's look at the next example. It's talking about the speed you drive and the time it takes you to get to college. So again, the thing you have control over is your speed, and this would be on the x-axis, that's the independent variable. The thing that you will measure as a result of your speed is the time it takes you to get to the college. So I think if you go a very fast speed, the time to get to the college will be a shorter time. If you drive a very slow speed, the time to get to the college, this would be travel time. It might be a longer amount of time to get to the college if you're going a slower speed. And here is what a scatter plot might look like. You will have all these different dots. Each dot represents a person answering the survey, saying what was their speed and how long did it take them to get to the college. And again, you'll notice you can see a pattern where in general, the dots are going down from left to right. When the dots are going down from left to right, that is called a negative linear relationship. Now there's sometimes where we are curious if there is a relationship between the independent and the dependent variable, but we're not sure. So let's look at this next example, your height and your GPA. So your height would be the independent variable, and does that have an effect on your GPA? It seems like a funny question, and it turns out that someone collected all that data, and let's say it looked like this. We asked different people their heights and different people their GPAs. And all these dots represent people's answers. And as you can see, it doesn't really make any kind of pattern. We can't make the dots look like any straight line going up or down. And in that case, when you don't see any patterns on the scatter plot, it just looks like random dots all over the place, you would say, this data has no relationship, which means that your height has no effect on your GPA, which is logical. It's what we would have predicted. So these are the three main cases we will deal with the most in this lesson. So as an example, here's some data that was collected. It is from a car rental company, and it's collecting, well, how many cars did they rent, and what was the revenue? How much money did they collect from doing that business in a year? So we have these different companies just labeled A, B, C, D, E, F, so 6 different companies, and here is their data. So it's asking us to draw a scatter plot. So the very first thing we should do to draw a scatter plot is to make axes X and Y, and decide what goes on the X, what goes on the Y. So the independent variable goes on the X, the one that comes first. In this case, that would be the number of cars that were rented, and the dependent variable would be Y, the revenue, the money they collected from that business. Okay, so I labeled the axes. Let's try to put the dots. So each company is going to be a dot. Company A, 63 and 7 billion. So that's about right here. Company B, 29 and 3.9 billion. So that's about right there. 20.8 and 2.1 billion. That's about right there. 19.1 and 2.8 billion is about right there. And 13.4, 1.4 is about right there. And lastly, 8.5 and 1.5. Okay, so this is our scatter plot. And though it's not a perfect straight line, and it rarely ever will be, you can see a pattern. You can see, in general, a straight line going up. So I would call this a positive linear relationship in this scatter plot. So here's another example. This was a company, and they noticed that there's a relationship between the temperature and the daily sales that they have. I don't know, maybe they sell winter coats, and so if it's not cold out, people don't want to buy coats. I don't know. But this is the data they collected. So we can tell that the temperature is independent, and that will affect the sales for this company. So if we were going to make a scatter plot, we would put the temperature on the x-axis and the sales on the y-axis. Now, I have this already done for us to save us some time, but basically you would plot all these points, and here they are. So for example, we can find this point. When the temperature is 20 degrees, we see that the sales are 103. And you can see each of these points. When the temperature is 21, we see that the sales are 104. Now, when we put all of this data together, you can see a pretty clear pattern. It looks like a straight line. It would fit closely to a straight line going downward. So this would be called a negative linear relationship. It means the dots are going down from left to right, and they fit closely to a straight line. So here is a summary of different kinds of scatter plots we might come across. The first one, where you can see the pattern looks like it's close to a straight line and it's going up from left to right. This is called a positive linear relationship. And you can see as the x, or the independent variable, gets bigger, the y, or the dependent variable, also gets bigger. Or you could also notice that as the x, the independent variable, gets smaller, the y also gets smaller. They move in the same direction. A good example of this would be study time and grades. So you can think, the more I study, the higher I predict my grade will be, or the less I study, the lower I predict my grade would be. That would be a positive linear relationship when both the x and y are moving in the same direction. Okay, the next one, you can see the dots are looking like they fit pretty well to a straight line going downward. This would be called a negative linear relationship. And that's where, as your independent variable, your x, gets bigger, then that has the effect of making the dependent variable get smaller. Or you can do it vice versa. As the independent variable is smaller, that would affect the dependent variable and it would get bigger. A good example of this that we often use is absences and grades. Meaning, the more you're absent, as the absences x get big, then it's likely that your grade will be lower. It will go down. Or the less you're absent, it's likely that your grade will go up. It will be higher. So in negative linear relationships, x and y are moving in opposite directions. Okay, the last two graphs on the bottom, these are very different and I don't want you to be confused. But one of them we've talked about already, where the dots are all over the place. This is what we call no relationship, where there really is no connection. It doesn't look like the X and the Y affect each other at all. Some of the examples I gave were height and GPA. It doesn't matter how tall you are, it should not affect your grades at all. Now, this last example, we won't use too much in this course, but it's important for you to be aware. Sometimes there is a clear pattern. You can see a pattern in the dots, but that pattern is not a straight line. In that case, we call this a non-linear relationship. So a non-linear relationship is a relationship, it's just that the relationship is not a straight line. It looks like some sort of curve. And there's plenty of examples of this in real life. I can think of one right off the bat. What if we measured as our independent variable age, and then we measured strength as our dependent variable? And you can think, okay, when you start off as a baby, you're very weak, then you grow into an adult and you become strong, and then as you become an old person, you lose a lot of your strength and become weak again at the end of your life. So that would be an example of a non-linear relationship, which is a pattern. That pattern is just not a straight line. Okay, let's review everything we've gone over so far. This first one, we will just make a scatter plot of this data. This data is measuring for, it looks like A, B, C, D, E, F, G, 7 different students. It measures their absences and how those absences affect their grade. So remember, the X is the independent variable and the Y is the dependent variable. So on the X, I will record absences. On the Y, grades, and we'll do our best. It won't be perfect, but it looks like the absences go from 2 to 15. So I'll say 5, 10, 15. And for the grades, it looks like they go from 43 up until 90, so we'll skip a bit from 0, 40, 50, 60, 70, 80, and 90. And we'll make dots. Each person, each student gets one dot. So student A, 6 goes with 82. Student B, 2 goes with 86. Student C, 15 goes with 43. Student D9 goes with 74. That's right about there. And E12 goes with 58. F5 goes with 90. And 8 goes with 78. Right about there. Okay. So that's the scatter plot. Now, it's not a perfect straight line, but you can definitely see a pattern. And when it asks what's the relationship between the two variables, I would say a negative linear relationship, meaning the dots are going down and they are close to a straight line. So that's a scatter plot, and that's what it shows, which means in practical terms, we predict as you have more absences, your grades will be lower. All right, let's look at the next question. It says, select the dependent variables for each of the pairs. So what I'm going to do, because sometimes it might ask you the independent variables. So I'm going to kind of, for each of these 4 examples, decide. So remember, X is your independent, Y is your dependent variables. So number of ice cream sold and temperature outside. I predict that the temperature would affect the number of ice creams sold. I predict, just using my own logic, that as the temperature goes up, that they would sell more ice cream. And by the way, when you have X going up and Y going up at the same time, that would be a positive linear relationship. All right, let's look at the next, maintenance cost and age of the car. Well, I predict that the age is what affects the maintenance cost, how often and how much you have to spend to fix it, maintenance costs. And I predict that the older your car is, the more you're going to have to spend each year. The more stuff will break, the more you'll have to spend to fix it. So again, this would be a positive relationship. As one goes up, the other goes up. Distance from Pizza Hut and the delivery time. Well, I think the distance is what comes first, and that affects your delivery time. And the farther away you live, so as the distance gets bigger, also the delivery time will get bigger. This is a coincidence. All of these are positive relationships. Sales in thousands and advertising expenses. Well, first you do your ads. First you pay for your ads, advertising expenses, okay? And that hopefully will have an effect on your sales. And the hope is that the more you spend on ads, the more you will bring money in for sales. All of these are positive relationships, coincidentally. But now we can go back to the actual question at hand, which was, what are the dependent variables? Well, those are the dependent variables. So the number of ice creams sold, that would be B. And the maintenance costs, that would be G. And the delivery time is what gets affected, so that would be F. And then lastly, the sales are what get affected, so that would be C. Okay, let's look at this. This is more of the same. We are going to determine what's independent and what's dependent. So again, I'll kind of make a table. I think that's the easiest way to see it visually. Okay, we've got A, B, and C, and here it asks, predict the type of relationship. So we will. So let's look, salary and education level. So the question is, what comes first and affects the other? So I think first is your education level. You decide to get the education you get, whether bachelor's or master's, and that should have an effect on your salary. And we assume the more education you have, the higher the salary you can get, in which case you'd have a positive relationship. They're both going up, moving in the same direction at the same time. Okay, amount you smoke and overall health. I think the amount you smoke comes first, and that will have an effect on your health. Okay, and here's a case where if you smoke more, I think your health will be worse. That's pretty much been proven already in science, so I hope none of you smoke. But in this case, you have one variable going up and the other going down. That's what we call a negative relationship. So remember, for a positive relationship, the dots are going to be going up. And for a negative relationship, it will look like a scatter plot where the dots are going down. All right, last one, GPA and number of siblings. Well, I don't personally think these are related at all, but let's say the number of siblings is what might affect your GPA. Maybe your house is crowded and noisy, so it's harder to study. So we would say that's the independent, GPA is dependent, but in my opinion, I highly doubt there is a relationship, so I would say no relationship. I would predict if we did this scientific study, you would see a scatter plot that looks like this, where you have lots of siblings and a high GPA, lots of siblings and a low GPA, or the other way around. I don't think there's a relationship there. Okay, let's do our last review slide, see if we understand everything. So, they're talking about definitions of positive and negative correlations or positive and negative relationships. Before we answer these, let's say what we know already. So, a positive relationship is where the dots are going up from left to right. This would be a positive relationship. And this is when you have X going up and Y going up at the same time, or X going down and Y going down at the same time. That's a positive relationship. A negative relationship has the dots moving down from left to right. So that would be a negative relationship where you have as your x gets bigger, your y gets smaller, or vice versa. As your x gets smaller, your y gets bigger. Knowing that, now we can look at this data. Positive correlation means as one increases, the other increases. Yes, that is exactly what we described in the orange scatter plot. Negative correlation means if one increases, the other decreases. Yes, that is exactly what we described in the purple scatter plot. Positive correlation means if one decreases, the other decreases. That's also true. They're both moving in the same direction. A negative correlation means no relationship. Not true. A negative correlation means if one decreases, the other decreases. That's not true. That would be called a positive correlation. Okay, so hopefully you all understand now about independent and dependent variables, positive and negative relationships and no relationship, and what scatter plots look like.